Okay, we're moving on to page 74, and you're going to need a calculator if you do not already have one. So there should be some calculators hanging on my cabinet door. Miss Woodlock can direct you to them. I'm going to let you pause the video. Miss Woodlock will give you the calculator directions, and then you can go get one, then come back and press play. Alright, so now you're playing the video, you have a calculator. Here we go. Let's talk about average atomic mass, and again, this is page 74. As we mentioned earlier, the mass on the periodic table is the average mass. Oh, excuse me. That's not what we're supposed to write here. Sorry. The weighted average of all existing isotopes for that element. This depends on the abundance of each isotope, meaning which isotope influences the average the most. For example, if your grades were a 90, a 90, a 90, and an 80, would the average of your grade be closer to 90 or closer to 80? You should be able to kind of answer this without even actually calculating the average. If you have a 90, a 90, a 90, and an 80, the average is going to be closer to 90. Why? Because there's more 90s. Average will be closer to 90 because there are more of them being averaged. The 90 is more abundant. As another example, if your electric bill is $100 per month for colder months, which in Texas is only about 33% of the year, and it's $200 per month the rest of the year, which again in Texas is the other 2/3, will your average yearly electric bill be closer to $100 or $200? And why? Well, if it's only $100 a month for a third of the year, and the other 2/3 of the year it's $200 a month, your electric bill should end up overall, on average, being closer to $200 per month, because there are more months where it's $200. The $200 is more abundant. Let's take this same idea and talk about atoms and isotopes. Nitrogen has 2 stable isotopes. 99.6% of all nitrogen atoms are nitrogen 14, meaning with a mass of 14. The other 0.4% are nitrogen 15. So would our average mass be closer to 14 or closer to 15, and why? It should be way closer to 14 because there's way more 14s. 99.6% are 14, only 0.4% are 15. It should be closer to 14 because nitrogen 14 is much more abundant. It is more common. Go look at your periodic table, the one that's on the back of your book. And look at what is the average atomic mass listed for nitrogen. Nitrogen is listed as having a mass of 14.01, which is 14.01 closer to 14 or 15? It's much closer to 14. So was our answer to part A correct? Yes, it was. Good job, go team. Everyone is so great. This is a rainbow, but I only have one color right now. There. Okay. So, now you. There are some problems here for you to try on your own. I'm going to have you pause the video, and then I'll go over them. So pause the video and try them yourself. All right, if you're playing the video, then you took some time to try these problems yourself. Number 1 says that lead has many isotopes. Of the lead atoms in the universe, 52.4% have a mass of 207.977. Another 24.1% have a mass of 205.974. 22.1% are 206.976. 1.4% are 203.973. The average atomic mass of lead should be closest to what? It should be closest to the one that is most abundant. The one that is most common. So that's going to be the one with the highest percent. Which, if we look at these percentages, 52.4% are 207.977. So it should be closest of all these options. It should end up being closest to 207.977 because that is the most abundant. And then number 2 is a table that gives us the masses of some elements, isotopes. We don't know which element. And some percentages. And this one wants us to figure out what element it is. It says that 88.45% of that, which is by far the highest percentage in our chart, is 139.905. So what we need to do is see what elements we can find that have a mass closest to 139.905. And if you go look at your periodic table, you have a couple choices. There's lanthanum, which is 138.91, element number 57, or element number 58, cerium, is 140.12. Which of those is closer to 139.905? 140.12 is closer. So cerium is most likely to have this isotopic composition because its average atomic mass on the periodic table is closest to the most abundant mass. Which was 139.905. When you're done writing that, turn the page. Let's talk about how they exactly calculate those numbers on the periodic table. Again, remember the mass on the periodic table is a weighted average of all the occurring isotopes for that element. That means that the weighted average accounts for abundance, for how frequently a particular isotope occurs. So, for example, the most common form of carbon is carbon-12. Therefore, the weighted average is closer to 12 instead of close to the less frequently occurring isotopes of carbon-13 or carbon-14. So we can calculate average atomic mass using a few steps. First, you need all the given information to be put into a table. Then you convert all the percents to decimals. To do that, you should know how to do that already. But in case you forgot, you divide the percents by 100 to change them to a decimal. Then you multiply the decimal times the mass for each isotope, and then add together the products from each isotope. So we're going to do an example together here. A sample of zinc contains 48.89% zinc 64. They've put that in the chart already. Zinc 64, 48.89%, and they've figured out the mass is 64. That's what this number is. Remember, that number is the mass number. 27.81% is zinc 66. That's in the chart already. And again, the mass number, that 66 is the mass. 4.11% is zinc 67. That's in the chart already, and again, 67 is the mass. 18.57% is zinc 68. That's already in the chart. The 68 is the mass. 0.62% is zinc 70. That's also in the chart, and the 70 is the mass. And it wants us to calculate the average atomic mass. So we're going to look at these steps. It says put the given information in a table. Oh, how convenient. It's already in a table. Check. Convert percents to decimals by dividing by 100. When you divide by 100, you can type this in your calculator if you want, but I'm going to point out if you just move the decimal twice, that's the same as dividing by 100. So 48.89 becomes 0.4889. 2781 becomes 0.2781. When you get to 4.11%, you still have to move the decimal twice, even though it looks like there's nowhere else to move it. So that means that empty spot, you're going to have to put a 0 there. This becomes 0.0411. 18.57, that becomes 0.1857. You get to this bottom one. People always tell me every year that, well, this one's already a decimal. I don't care. It's not really already a decimal. It's a percent. You still have to move the decimal twice. You still have to divide by 100. So it just becomes a much smaller decimal. And you put those zeros in to the empty spots. So we've now made decimals. Our next step is to multiply. Check this off. We did this. Good job. Step 3, multiply the decimal times the mass. So get your calculator, and you're going to do 0.4889 times 64. 0.4889 times 64. And you don't have to write down all of these digits. I'm going to go ahead and do it just to keep you from being confused. If you want to round to like the hundredths place, you can. Or you can write down all the digits. I'll leave it your choice. But each one of these, I'm just doing like this times this equals that. This times this equals that. This times this equals, and so on, so forth. So you can type these in your calculator. Double check you're typing it correctly and getting the same numbers as me. This times this. This times 70. And then I'm supposed to add them all together. Just add them all up. And again, you can use your calculator for this. Save yourself some time. You're allowed to use a calculator. Don't waste a bunch of time by doing third grade arithmetic in your head. I assume since you passed the third grade that you know how to do this arithmetic. And when I add all this up, let me double check I didn't typo anything. No, I think it looks good. So when I add all this up, I'm getting 65.4595. Which is pretty close to what the average on the periodic table is. They rounded a little more than I did for the periodic table one, but pretty close, pretty good. Okay. So, at this time, go to your stamp page, your Unit 2 stamp page. And let me pull it up. Here. Okay. By now, it should be, again, depending on if it's an A day or a B day, either the 14th or the 15th. And pages 75 and 76, finishing them, that's going to be a stamp. There's also an activity for you to do today called the M&M Lab. If Miss Woodlock thinks you're going to get that far, then she may also assign that lab today. It's pages 77 through 79, and that'll also be a stamp if she thinks you have time for it. So I'll leave it to her. I'm going to pass it off to her. We'll, yeah, I believe, let me double check before I say this. Yeah, there's only one other video for this unit, and then you'll be done with the unit, so cool. Get to work.